All right, everyone, let's go ahead and get started. Welcome to the the May session of Dr. Spotfire. My name is Neil Kanungo, and I'm your host. Today, we're going to be talking about enhancing visual perception in Spotfire dashboards. As a reminder, we put all of our recorded sessions on YouTube. Be sure to subscribe. We put out regular quick tips and Spotfire demos and tutorials. You can ask questions on there and learn things as you continue your analytics journey. So, a great YouTube channel, highly recommended. We also have our new TIPCO Data Science channel, also recommended, and this is includes Spotfire but expands to the broader TIPCO Analytics portfolio, their Predict portfolio, and includes our real-time streaming, our TIPCO Data Science Team Studio, Statistica, and combined analytics apps. So I recommend subscribing to that as well. For today's session, I am super excited to introduce Michael O'Connell. Some of you may already know Michael O'Connell. He's our Chief Analytics Officer here at TIPCO and my boss. And Michael and I spend quite a bit of time jamming out over data visualization and Spotfire dashboards and visual analytics apps. So we thought we'd kind of tag team and show a lot about visualization theory, visual perception. Michael's written a book called "A Table's Worth a Picture's Worth a Thousand Tables," and it is a data visualization book. He has a lot of experience in this area. So I'm very excited to introduce Michael today. The agenda, we'll be talking about some visual analysis goals, contextual perception, choosing displays, graphical elements. I'm going to finish with some direct technical tips in Spotfire, showing you exactly where you can click and how you should do some specific things to implement the visual design theory we're going to show you. And we'll also close with some examples of some before and after restyling of dashboards. If you have any questions throughout the session, be sure to put them in the Q&A. We'll use the chat for general information that we have to give out to you if we have links and other things to share. But please put your questions in the Q&A. With that, I'm going to hand it over to Michael. Michael, are you ready for us here?
Yeah, I'm ready and honored to be here as part of the Dr. Spotfire series. It's really a wonderful series that Neil runs here, and excited to get a chance to speak to you folks directly. As Neil mentioned, we're up late at night trying to figure out how to fine-tune our visual analytics displays and presentations. And really, it's all about getting insights from data. That's what visual analytics is for. It's not so much about pretty pictures or artwork. It's about getting insights out of data from visual displays through interactive discovery. We'll get into the Ben Schneiderman original mantra when data discovery was invented all the way back at the beginnings of Spotfire in a moment. But the idea is you look at an overview. Our brain is very well tuned to picking off patterns from an overview. So make that overview strong, then filter, mark, and zoom down into the region of interest, and then get the details on demand. That was the original kind of premise when Spotfire was invented from Ben in his early papers, and also Chris Alberg, who did the work with Ben to found Spotfire. And this still applies today, and actually more today than ever. The last mile, getting attention to detail, is where the magic happens. Neil is the master at that. And then, visual perception as a science rather than, again, pretty pictures. It's about getting insights from the analysis. And, the data is important. So I talk about representative data. You might get some supplied data. You might have a lot of big data at your disposal, but and typically you want to get to the data that represents the business problem. That often involves enriching the data you're supplied with, and then applying visual analytics and data science to amplify the end user's cognitive abilities to better understand the data that's being put in front of them. So we're going to talk about those three types of areas: exploration, exploratory analysis, sort of pioneered by John Tukey. Visual analytics, pioneered by Ben Schneiderman and Chris Alberg with Spotfire, and then presentation, which is more in the Stephen Pugh Tufte region. We're going to cover those three pillars in today's discussion. Now, just a little bit of background on the history. John Tukey invented this area of exploratory data analysis, wrote the book on it, so to speak, and so really a great linguist. The greatest value of a picture is when it forces us to see what we never expected to see. It was one of his great quotes. But he he invented the word bit. He invented the word software, and really a pioneer of this. He was a professor of statistics at Princeton. Now, he did invite Ed Tufte, who was a professor of statistics and comp sci at Yale, down to Princeton to give a series of lectures one summer. That turned into Ed Tufte's first book, The Visual Display of Quantitative Information, where the principles that Ed laid out in that, a time and memorial, show all the data, maximize the data to ink ratio. I think what we're going to focus on today, comparing different pieces of data, revealing the data at several levels of detail, showing multiple plots of the same type to leverage the reader's investment, use color sparingly. These are all terrific principles that sort of lay it on top of John's pioneering work, and the Princeton and Yale groups became the leaders in this. And if you think about what Tufte talks about with data to ink ratio and taking away chart junk, take a look at the graph on the left with all those adornments that are not really adding much value, and then take a look at the chart on the right. It's a much cleaner, Tufte is a bit of a minimalist, takes away ink wherever possible. But, he also talks about chart junk, and there's a lot of chart junk out there these days. And it's good to be reminded of doing a good job on the data to ink ratio and avoiding chart junk. Now, Ben, Schneiderman came along after those two guys, founded the Human-Computer Interaction Lab at the University of Maryland. At the TAF upcoming TIBCO Analytics Forum, we're going to have Ben on the main stage. We're going to have a conversation with him about the beginnings of Spotfire. And The Eyes Have It is the paper that I was referring to earlier. Overview first, zoom and filter, then details on demand. That was one of his original works, and along with Chris Alberg as the intern student, came up with what ended up turning into Spotfire. So we're going to cover this interactive information visualization world today. Again, it's one of Ben's quotes: "The purpose of visualization is insight, not pictures." So let's talk a bit about contextual perception and how we can get information from visual analytics. And it turns out that both speed and accuracy, both of those are important. The human brain can actually process an entire image that the eyes see for as little as 13 milliseconds. We're very good at detecting overall patterns. And it breaks down into three pieces: detection, the geometry encodings of the values; assembly, grouping the symbols to construct the pattern; and then estimation, assessment of the relative magnitudes. Those all happen in a very short amount of time. So here, for example, is where we've leveraged that in one of our pieces of work that is going to be on display at the Analytics Forum. This is a notion where we're using visual analytics to find patterns in wafer maps from high-tech manufacturing. You can see here I've got this heart-shaped pattern, and we've built a solution where you can, as a visual, people can understand and tag different patterns. So if I tag that group that I just highlighted into this heart pattern, and I've been tagging into other patterns, whether it's a donut or a Pac-Man or a ring, this allows the end user to visually tag a group of patterns, and you can see those patterns on the top right-hand side. So with that visual analysis as the way to get a training set, if you will, we can then fit a machine learning model to encode those patterns, and then we can apply that machine learning model on the event stream to classify incoming wafer maps into that set of patterns. So that's an example of how visual analytics is leading the way when it comes to actually machine learning recognition, automatic recognition of patterns. Here's another one that I put out there as for folks to see if they can guess what these patterns are. This is data from a presentation that one of the data science team gave at TIBCO Now, and this is electric power usage patterns from Friday morning on the left-hand side, through to Sunday evening on the right-hand side. So see if you can guess what these patterns are, where you've got, in this case, high usage during the daytime on Friday, during the daytime Saturday, a little bit less on Sunday, and then these other patterns. So I'll give you just 5 more seconds to think about this, but then I'll, in the interest of time, go through it. So the first one is a business. So it's a business that runs every day. Maybe it has a little bit less business on Sunday, but runs every day. This next one is more like a restaurant, right? You can see the activity in the evenings on Friday, Saturday, and Sunday. a little bit during the day. Maybe there's a bit of lunchtime dining or whatever, but this is more like a restaurant, nightclub. This looks more like, a consistent pattern. So this is probably, a single family home type of scenario. This one just looks like a mess of noise. So this is probably a measurement error, a broken meter type thing. This one is probably a downtown business, right? You've got a nice piece of activity on Friday, less so on Saturday, and pretty much nothing on Sunday. So maybe this is like a department store that's downtown. And then finally, a set of condos probably in this last case. But you can see how the patterns are very clear. When you look at them, you can recognize the patterns, but you can't quite attach the label to the patterns. And so that's when you have to kind of think more carefully and do more analytics. So that the notion of comparing lines, points, colors, and shapes is important. And that kind of came up in the last example. And it turns out we're not great at estimating differences on graphs. We're okay if they're lines, but they're not too steep. We're not very good at ordering color hues. It's only a limited number of color hues that we can process. So you've got to be careful about not using too many colors. Red is emotional, can be perceived as larger. Shading, darker regions sometimes, or larger regions appear darker and kind of vice versa. And Weber's law is, the probability of a human detecting a difference in two lines is related to the ratio of the line lengths. There's some tricks you can do to increase perception. Sorting by the order of the categorical values, for example, a faint grid line can help. Putting your scatter plots, banking those to 45 degrees so the average slope is 45, so that the differences from 45 can be more rapidly discerned. These are all tricks you can do to enhance perception. But let's take a look at this notion of estimation. And this is some COVID data, and Neil and I have been poring over COVID data this last year or so. These are raw case counts from Germany, for the last year or so. And you can see there's a lot of reporting gaps there where, just reports are not sent in on Sundays or, that sort of thing. And then it kind of overcorrects on Monday when you get the last 2 or 3 days reports. Now, it's been popular, even in the New York Times, who I greatly admire and respect, to use this, moving average. I don't like it. It's too noisy. It overfits the data. And we've been looking and building out methods to smooth this out. We've been using a super smoother function invented by Jerome Friedman from Stanford University. And we think this not only captures the trend better, but it gives us a baseline curve that we can start to do things like estimate the first derivative to get the velocity in the case counts and things like that. You might be more familiar to today's audience with the United States. Again, here's that overfitting of the 7-day moving average. You can see this gap here at Thanksgiving and Christmas, where people maybe they got sick, they just didn't go to hospital, who knows, but that sort of shows up. But there's generally that same level of gap, not as bad as Germany. But again, look what the super smoother puts through that and gives us a curve that we can really work with from a first derivative basis at least to understand the velocity.
And I think, Michael, on that last one, I think it's like really important point where do you want to represent just the raw data, and where does using some of these tricks available to you as an analyst, some of these statistical tricks, help communicate what you're trying to communicate? We're trying to communicate an epidemic curve. Like those gray bars, that's just the data that's being reported. We see those dips because a lot of places weren't operating during the holidays. People had time off, so you obviously had data reporting issues, but that affects what the actual epidemic curve would have looked like. So, as you communicate this, as you try to improve the estimation of what your audience is able to do, this is where using smoothers, using moving averages helps them estimate the data better, right?
Right, exactly. So you shouldn't be quoting, a case count of 300,000 per day. That would be, someone doing an alarmist kind of politically motivated report, right? Because that is a number that's making up for some of the underreporting that's happened earlier. So yeah, I mean, the case counts have, thankfully dropped now below 50,000 per day in the United States. But I think, if you look at the peak, we're up above, around 200 or so. We're not really at 300. That's kind of a reporting artifact.
And likewise, those drops were those dips where, it was the holidays and things weren't being reported. We might feel a little too comfortable saying, oh, the cases are dropping very quickly.
Right.
Even looking at the moving average, you might think it's dropping very quickly. And that affects our ability to estimate the rates of change as well, right?
And so be careful of this sort of thing. And I go back to, just slide back to John Tukey's slide, because one of the things I skipped over there with John, this last point, which I definitely take to heart. I was so lucky to get to meet John before he died. He gave a lecture at the University of North Carolina at Chapel Hill that I went to, but visualization is often used for evil, twisting insignificant changes and making them look meaningful. Don't do that crap if you want to be my friend. Present results clearly and honestly. That sort of thing. I know we've seen that in our living room during the pandemic as people have highlighted, these gaps that we're pointing out are reporting inaccuracies for their own kind of narrative, to support their own narrative. Really got to look out for that. And our job is visual analysts, statisticians, data scientists. We're the keepers of the scientific method. We have to really just stay with the data, stay with the science, and do meaningful things like this to get a good curve through the epidemic data and to get a good estimate of the velocity. It's our responsibility to data first. We've got to lead with the data and with analytics that get signal from the data and not be biased in any way. Rhode Island.
And I was just going to quickly mention, we do have a video on YouTube on how to do the super smoother. So I'll put that in the chat if anyone's interested in doing this.
Oh, perfect. Yeah, thanks, Neil.
Yeah.
So Rhode Island was another interesting one because they only reported weekly, and the other states were reporting daily. And so if you look at the Rhode Island data, next to someone else's data, each of these points here represents 7 days of data, whereas the other states have got maybe they've got a gap on Sunday, but not every other day. So you look at that and you think, wow, Rhode Island's really peaking, but you put the super smoother curve through it. No, it's not. These are weekly points, and if you want to get a smooth curve across a daily case count on the y-axis versus time, that's how the super smoother gets rid of those reporting artifacts. So pretty important stuff in terms of getting accurate inference is the topic we're on right now, or accurate estimation. So we're actually moving now from estimation to inference, and this is the order of human perception ability. From the best we do is when we put data on a common scale and we can really estimate the difference between, say, these two lengths of these bars here. We're very good at that. We're also pretty good at looking at points in the same way and doing a comparison on a common scale. Where things start to go awry is when we start looking at areas and volumes and say this width here. You can tell that's wider, but you can't tell by how much. You can tell that's a bigger circle, but you can't tell by how much. We're just not good at discerning one area to another in terms of the quantitative difference between, say, this point and this point, or this intensity and this intensity. So we got to make, when we present our graphical analysis, we want to make presentations in a way that people can interpret them and draw inference from the analysis. Now, Tukey also invented this mean difference plot, or one sort of incarnation of that, or in the same spirit, is the taking a difference here. So rather than looking at trying to discern the differences between these bars here, what is the difference between them? If you look at, say, the gap to the average, that sort of mean difference plot concept gives you a way of really discerning these cities here in terms of this items purchased number. Mean difference plot in its raw form is to take the difference and plot it against the mean, and you can really get some good separation when you do that. Versus just looking at the raw data. So this is the Tukey plot that we still use it quite a bit. And if you want to communicate where the differences are versus just the raw data, it's a really good trick.
Yeah, and I think with that last one, you want to make using 0 on the bottom of your axis. You don't want to start changing, in this example, it's a horizontal bar chart to be your x-axis. You don't want to start changing that to overemphasize the differences between the bars, because that can give people a false interpretation. But if you do want to look at the change of these, doing this mean difference where you take the average of this and you show the deviation from that average, can show a little bit of a change. But you have to be careful there not to overrepresent what's happening in the data.
Yeah, but just taking the difference from the average, you can see, that Boston pops out to the right, Seattle pops out to the left. You get a much clearer representation of the differences than just showing, you're kind of wasting all this ink up until, this point on this graph, whereas this is really a good use of ink on the, using the difference. Length and area. We could have highlighted area too, I guess, here, Neil. But there's only so many colors that we can firstly distinguish. But secondly, we're not good at discerning that is this slice bigger than this slice or this slice. We just do not do well with areas. For that reason, as much as I love circles, and I had a great time on Pi Day, it's not a good way to communicate. It's not a good way to draw inference from a graph. It's much better to put a bar chart here, or perhaps a mean difference type bar chart where you can now clearly see the differences here. You can't really tell that is much different from this in terms of area, right? So do be careful about pie charts and other forms of circular plots. Be careful of radar plots and spider plots as well.
Yeah, I think it's interesting is all of those pie charts look identical,
Right.
but the same data is represented directly below it. And you can tell, like, okay, Los Angeles, you have this increasing bars, and New York, you have these decreasing bars, or they're just arranged that way. But you can tell that the bars are of different lengths there, and our eyes are much better at interpreting that.
Right. So actually, totally reverse trends in New York and LA against these different departments, and here you can't even tell the difference. So these are just wanting to make sure that you present the data in a way that the human can perceive it, in the optimal way. Angle and slope. Bill Cleveland, another pioneer in this whole thing, invented this idea of banking to 45 degrees. In this case, we've got a couple of different, we've got city and highway fuel efficiency on the axes, and we're looking at a number of different cars. And we've got, blue, a certain type of car, and yellow, a different type of car. And we're able to sort of discern that pattern much better when we bank the graph to an average 45-degree line versus this one. It's just harder for the human eye to kind of, to figure that out. So the recommendation in general is if you can make the slope an average of 45 degrees, you have a better chance of discerning any differences in the subgroups that you're plotting on this. And that's, again, due to Bill Cleveland from Bell Labs.
Yeah, and that last one, if you're trying to look at a point that's off this, these are the same graphs, by the way. They're just at a different ratio representing. It's the same data, same straight line fit. And if you're trying to look at a specific outlier, specific point, and see how far is that from the line in the x coordinates and how far is in the y coordinates, you start to get a distorted view. But when you have that banked at 45 degrees, you're getting a better representation of, regardless of like the x and y coordinates, since it's the x and y coordinates will be more, how do I say this, like symmetrical, and that way you're actually getting a better understanding of how far is that point from the, again, on the top one, I don't know if my mouse will show, but you can see, I don't think it will show, but there's like a kind of a couple dots there in the center that are off the straight line fit. And those couple dots in the top chart look, much closer to the line, and then in the bottom chart they look farther. So you could pick any point on this and try to compare that point on both of these charts and see that on the wider chart they look closer to the line, and on the square chart they look farther from the line. So
very good. Yeah. So I think another thing that is an important thing to do is to try and keep the scales common when you're making comparisons. This is a graph from our latest version of the COVID application on our website. And this is where we've added the vaccinations data recently. So let me run this video, and you'll see that on the left-hand graph, we have cases per 100,000 people on the y-axis versus time. On the right-hand side, we have vaccination rate on the y-axis versus time. And we're now going to step through a number of countries. And so we're going to start here with the United States, and we can see the cases dropping, and the United Kingdom. We can see the vaccination rates, quite different. High for the United Kingdom, United States, lower, for France, and Germany's got a tick up there. Italy, not too many vaccinations. Turkey, not too many vaccinations. And then India, which is in the news at the moment, is low with respect to the cases and the vaccination rates compared to the rest of the world. But we have been reading about the massive underreporting that's going on in India. So while we've set the axes to be fixed as we're comparing the countries, we also have added the zoom slider as an optional feature, so that when you get to a country like India, you can slide the zoom slider around, change the y-axis reference points, and start to see the trend in the cases. It, hopefully it's going to start bending over here. The vaccination rates are pretty low. The way you read this is the top one is the partial vaccination rate in India versus the average for the world here in pale blue. And the other line here is the fully vaccinated versus the global average. So they're ramping up rapidly the vaccinations, but the cases are also ramping rapidly. And now you can get a sense of, we're in a race here between vaccinations and cases in the sense, but you can now, with the Zoom slider, you get to study those patterns a little bit more. But when you don't have the Zoom slider turned on, you get to quickly, your eye can see the comparison on the same scale between, all of the countries. So we've really paid attention to detail in this. Part of this, and now we're moving on from estimation to inference. Now we're at insights, and now we're at the Ben Schneiderman, visual analytics mantra. He called it 3 levels of understanding: overview, number 1; number 2, zoom and mark to the area of interest; number 3, details on demand. Getting to that careful, detailed study of the data that's underneath everything. And here's a nice example of how this works. And Spotfire really is the application that invented brush linking. We, I try not to be biased, but we still do this better than any other tool. It's very difficult to do, just marking and filtering and interactive data discovery in other tools, because they're always going back to the database and so on. But here in Spotfire, I'm sliding things around here to figure out miles to the new store. I'm making a click here on miles to new store versus income in the top left-hand corner to see which folks with what personal income live close by to this new store. These are all what-if scenarios that I have like ultimate flexibility over in terms of the slider, in terms of the marking, and back and forth to the graph. This is really when I talk about brush linking and data discovery, there really is no other tool that does it at that level of detail and gives the user that much control. And it all goes back to the invention of Spotfire and that 3-level, what Ben called the visual analytics mantra that we'll be talking about at the Analytics Forum: overview, filter, mark, and zoom to the area of interest, details on demand, and all of the interactive brush linking and sliders and everything that kind of went into the early part of Spotfire that we've doubled down on over the last 20 years. It gives the user that really immersive, interactive brush linked experience. So how do we choose displays? We've touched on this a little bit, but you really got to think about the attributes of the data. And this is the data's DNA. What type of data do you have? A categorical text or a continuous number or a date? Every attribute type requires different preparation and different feature engineering in a preparation for machine learning or visual analysis. So a numeric scale is very different to a categorical. In the categorical variable, you might have no scale, you might have a binary, or you might have ordered, you might have frequency counts, you've got spatial data, time data. These have fairly complex hierarchies. And so you've got to understand all the different data types when you do that. And what are you trying to communicate? Are you trying to communicate a relationship between two variables, a distribution of a single variable? You're trying to compare many items, or you're trying to look at a few categories or many categories, or are you looking at relative or absolute or different periods over time, or are you looking for a static cross-sectional versus a longitudinal analysis? Kind of, Neil created this great cheat sheet about how to think about what it is you're trying to communicate, either with one variable or two variables or multi-variables or time or that sort of thing. So we have, we created Spotfire recommendations some years ago to automate this process of choosing a chart. We broke up the data into all those types of data that I just mentioned. And then we started to look at what are the options for doing univariate, bivariate, or multivariate charts. And these are all the options that you have. And we came up with an algorithm that allows you to we firstly go through and we pick off the metadata. We get the variable relationships, and then we push that back to the user in a series of sorted visuals based on the test statistic for the relationship. They're sorted in order of the strength, but you can see some of them are colored by different variables. Some of them have a density arrangement. We pick up nonlinear relationships here, for example. All of the relationships are ordered with respect to the test statistic and presented to you in that order. But you're able to pick off whether it's a scatter plot or a density plot or a bar chart, the underlying algorithm that takes the variable relationship data and turns it into a graph, chooses the graph type and the coloring and categories and so on based on the inbuilt AI engine inside of Spotfire. So behind the scenes, we're doing all the metadata and features and variable relationships inside of the inside engine. And then we're giving you the graph selections in order of their strength. And then you can also click more like this, and we'll go back to that relationship and do some different visual displays, because we have a ranking of the visual displays based on the metadata, the number of categories and so on that we push out there. But if you drill into that more like this, the things that don't bubble to the top, we surface more of those in the AI engine and give you a few more choices on the types of charts that you use. Now, we also applied this approach to being able to interactively mark points on the graph. So if you find these outliers, what's going on behind the scene is, well, there's an error on this slide, but we're setting up a 0, 1 variable, and we're looking at what the difference between those outliers and the rest of the data through basically a logistic regression. And we're coming back with the most important variables that explain that difference, again, in sorted order of the recommended visuals. So
yeah, I really love what's happening there underneath Spotfire, because we're talking about all of these approaches to visual design theory and how you should consider your data, how you should represent your data, communicate it, what type of variables are you using, what are the relationships of those variables, how can that best be communicated. And rather than have you go through and do these test statistics and try out different combinations of variables and say, oh, there is kind of a trend here, a trend there, with a simple click, it's doing all of that for you. It's following these design principles to get you started, right? It's not necessarily going to do 100%, but it's getting you started with the doing a lot of that grunt work for you on what is happening in your data and what you might want to communicate.
Absolutely. And then, some of the charts, we don't have every chart in there. We don't have a box plot in the recommendation system yet. If you want to vote for that, please do. I would like to get that added. But some of those can be reconfigured. Once you've got the basic display from some of the others, you can then reconfigure those in post-processing of the set suggested graphics. Now, in talking of displays, big effort this year. I'm sure everybody's heard about our Spotfire mods that we've introduced to expand the graphics palette. So that set of graphs that you saw that we're using in recommendations and that we're offering through the built-in features of Spotfire, we're now expanding that to allow people to build their own plots, whether it's a network chart or a specialized graph here for the oil and gas industry, or routing analysis. These are charts that are just not in the product and were never kind of meant to be in the product. So, but giving the ability for folks to come and do like a D3 type analysis JavaScript that is easily mapped to the sliders and to the filters and checkboxes and so on, to give the an additional graphic inside of the analysis. Now, obviously it's going to take a while for us to get these into our recommender engine, but that's the way we're kind of building up from the base graphs recommender system and now into extending the palette. So choosing layouts, I think, Neil, I was going to hand off to you here. And do you want to talk a little bit about choosing layouts and getting us to that newspaper style that you've been working on lately?
Yeah, definitely. We also have a couple questions, so I was just going to take a quick moment to answer one of these. So someone was asking about pie charts and what about when you want to make a point about extreme situation. So I think, pie charts can be used. There are appropriate ways to use them. So for instance, if you've burnt up a lot of your budget, 85% of your budget, and you just kind of want to see that univariately, then that is that can be a very useful way to use a pie chart. Pie chart's going to show kind of a relative. The bar chart's going to show you relative to each other bar, as well as what is that specific value. The pie chart is really more about how is it relative to the whole. I just took a quick screenshot of so we are to do a wedding this year, and I have some of our guest list in the invite. And I just took a looks like my internet connection is a little unstable. Hopefully you can hear me okay. But I just took a quick screenshot of just the people that have RSVP'd and invite side by side, so I can see myself, my fiance, who has invited.
It's like Neil's connection is breaking up there. Let's see. I think there's another question.
Let me turn off my video, and that might help. I'm gonna turn off my video feed. But Michael, yeah, if it kicks out again, feel free to.
Okay, no worries. No, I was just going to answer a question there from Joel on
Yeah.
regressing Y on X and X on Y to look at measurement error. You know, that's something we're very proud of having R and Python as inbuilt engines inside of Spotfire. And you can do whatever, you know, measurement error method you want if you create a data function. The best data functions for that would be available through R. So happy to help you set that up, or maybe there's some videos that you can go watch about how to create a simple R data function. In fact, the super smoother that Neil was just talking about is based on a small piece of R code that, you know, Joel, you could do that yourself for the measurement error method. So do you want to keep going, Neil, or?
Yeah, let me try to move along. Hopefully my internet holds up. All right. And, you know, just for the record, you know, we typically kind of keep Dr. Spotfire around 30 minutes. I forgot to mention this at the beginning. Today's session will be a full hour. So we are about a little past the halfway point here. So just a kind of heads up for those of you attending and might have other things going on. So moving forward, choosing layouts. So I wanted to explain a little bit about different layouts. We've talked about this in the past. People typically read from top to bottom, left to right, but there are, you know, some common layouts, such as like if you have some main insights that you want, putting those kind of largely at the top, and then having some contextual supporting graphs below that is a good way to represent a page. There's also if you have a very large map or analytic results, maybe you're doing a big forecasting and that's the main forecast, or a budget calculation, that can be this main chart. Maps tend to draw people's attention a lot. And then having contextual and supporting charts around that. And I put table detail at the bottom. I like to put tables and granular information at the bottom right over there. So that's that type of layout. And then this I like as a analytics app. So on the top right, you're seeing the type of layouts here. So an analytics app might be where you have a sidebar and you have different sliders and input fields, and you're using some machine learning algorithm or some type of proprietary calculation, data function, and then you're getting a series of results from that and kind of comparing these results to look at what's happening in your business process. Another layout is we've shown this in our COVID live reports. There is our newspaper style. There is also a video online that shows, well, this is looking a little choppy, but there's a video online that shows how to make a scrolling page in Spotfire. You can kind of do this newspaper style as well. Let me move on here. So we have let me see if I can jump to our COVID live report real quickly. All right, so this is that newspaper style COVID live report. You can find us at tipco.com/COVID-19. And we've added our new vaccination page. So each of these little tiles have a kind of sub-analysis in it that allows you to see different parts of the COVID epidemic, but not overwhelm someone with too many tabs. So we have the vaccination discussing. This is showing in the US. This is Michigan's case rates and vaccination rates. And we also have added a Spotfire mod in here, which is our animated bubble charts that shows how vaccinations have changed per state over time, what the case rates are. So we're seeing the case rates move to the left as cases were declining. The size of the markers increase as more people are vaccinated. The color changes as the rate increases or decreases. And as more people are vaccinated, we're seeing all of these move up. So definitely play with this. This animated bubble chart is also on our TIPCO community, and you can add this as a Spotfire mod if you're using Spotfire 11.
And you can see how we're doing very well here in the United States, as points for individual states are generally moving up and to the left. As more people get vaccinated, the points go up on the y-axis, and as case counts go down, they go to the left on the x-axis. A couple of outliers there. You can see Michigan sort of going in the wrong direction there, but looks like we're now in the middle of April. 19th, 20th, 21st of April, you can see Michigan starting to move to the left as we get to the end of the month here. And we're now, as of yesterday, the 3rd of May, Michigan's kind of back in the pack. So that's really great, great to see that. But having that time course trajectory overlaid on 2 axes does tell a nice story. Thanks, Neil.
Yep. There's various different pages in the COVID analysis where we try to implement a lot of this visual perception. So the reproduction estimates is one of my favorite examples. And one thing I'll show here with that, I think it's worth a quick demonstration of this is, color can be used to communicate different things. We will talk about different color themes, but let me go here, overview by country. So I can see where the reproduction number is increasing or decreasing, but I added a button here to show the 24-hour change. So you can see what countries are getting worse, what countries are getting better. It just quickly switches that to a binary or diverging theme to see what's getting better and what's getting worse. And then this is showing relative to the number, to a reproduction number of 1, where we want to be below 1. So this is showing what that is relative to the absolute value. So a lot of these concepts are shown in the COVID dashboard, if you want to check out. Now let's move forward with some graphical elements and some things kind of expanding on the philosophies of the researchers and thought leaders in this space. So first is, this is actually built by John Henderson of Enertel, who was in our last Dr. Spotfire presentation. And it's a really good representation of contrast and context. You can see that there are these wells that are active in these onshore rigs. He uses very dark background here, but he's really brought down the background. He's made it more subtle. It doesn't distract from the data. The data is highly emphasized here. And I think it's also worth pointing out that when you are using a light background, you might use darker values to represent increases. But when you use a black background, you use a lighter value to represent an increase, the highest numbers there. And so moving on, so this is from a Stephen View book called Now You See It, one of my favorite data visualization books. And on the right, we're seeing newspaper, television, radio, and they're all different shapes. But for these 3, but it's very hard to see that they're different shapes. Using color here is actually a better way to represent these different shapes. Another thing about shape, or these different categories, another thing about shapes is if you are using shapes as markers, if you use hollow shapes like a hollow square, a thin plus, a thin X, it is actually easier for your eye to break that out versus having these filled in shapes, which all kind of tend to run together. And then color, we talked about hue. Michael mentioned hue and how if you have too many hues, it can be, and a hue is, by the way, the different colors on the color wheel. So these are all different hues: the purple, the blue, the green, the yellow. If you have too many colors, your eye is not really making sense of what's happening there. There's a lot of noise. So on the right, it's really hard to pick out where the red circles are. But on the left, it's very easy to pick out where the red circles are. So just trying to understand what is it that I want to communicate. You really want to be very specific about what you're trying to communicate. Think about your data. Think about how your data is visualized and emphasized, and be sure that what you're trying to communicate is very clear on that page. You might have a different page that you are using other colors or more colors, but to have only 1 or 2 colors on a certain page where you're trying to emphasize maybe what's happening in these red dots is very useful. I like showing this in terms of data to ink ratio. So this is showing how just removing all of this extra ink actually helps elucidate the insights with the data. So all these shadows and labels, sometimes grid lines, and actually all this stuff is actually distracting from what's actually happening with the data. I think, can feel like we want to make things look very flashy and attractive, but really just making something simple is more effective and attractive. And I also wanted to show something similar with data tables. This was very useful to me. I used to kind of over format my data tables, But if you remove a lot of this extra borders, extra colors, and especially when it gets into aligning the text, you left align your text, you right align your numbers, that can make things a lot more readable. And you definitely want to right align your numbers so that your decimals line up and you get a better understanding of the larger and smaller values. Okay. So here, so we've talked about color a lot in the past. I don't want to spend too much time on it, but just a little bit of, I think it's worth touching on a couple points, revisiting a couple points. So this is your color wheel. As you go around the wheel, that's your hue. As you go lighter and darker, that's your tint. Colors that are adjacent to each other are analogous, opposite to each other complementary. Triadic colors are equally spaced out. And we're going to use that in color themes on the next slide. But warm colors kind of create a heightened emotion and activity if you really want to emphasize things, draw attention to it. Cool colors are good for like reports, and you're just trying to just represent the data, not trying to draw a lot of attention to things. So talking about the color wheel, the analogous, complementary, triadic, the 4 types of color themes are sequential, which is going from a minimum to a maximum value. It's all numerical. There's diverging, which is numerical, but it has a center point and it's going from one extreme to another extreme. And that's diverging. Binary is 2 colors, like true or false, A or B. And then qualitative is there's no ordered, it's categorical, so that's non-numerical, and that's qualitative. And so this is on our cheat sheets on our TIBCO community, if you want to see all these cheat sheets, as well as a chart selector that Michael showed. There is also the color modes on gradients and categorical, those type of things are also selectable from the Spotfire color dropdowns. So just to kind of show this is diverging. This is a 2012 election, Romney and Obama. And you can kind of see where Romney won in red and Obama in blue. But once you get in these purple areas, it's really hard to break out who won. And so just by adding a center color of kind of off-white, now you can much better see this diverging color scheme and who won which county and who won it by how extreme. And then you can further elucidate that by making it binary and just saying, is it either red or blue? And you can see who won each county directly that way. And if you want to see where, let's say, Obama's greatest victories were, they were kind of in this strip here, they were down here. You can see his largest leads there. And this is by using a sequential theme. And same thing for Romney, Rez is using a sequential theme. These are various color scheme tools that I would recommend. I wanted to talk about contrast as well in terms of context. So if you look at this varying contrast, it might not be immediately obvious, but that center bar is the exact same color. It is all that central rectangle is the same gray. So if I go here, you can see that better. That's the same gray across the board. But because the context behind it is contrasting with it, it's actually giving you an impression that it's a different shade along here. And so when you're building a color thing, let me open this up. All right. So when you're building a color thing, you want to have something with a light tint on one side and a dark tint on the other side. So if I make both of these the same tint, even though they're different hues along the color wheel, they all look like they all run together quite a bit. But if you start to vary this, then you're able to see the colors differently. Your eyes are going to be able to pick it apart differently. You can print it out on black and white paper. You're still going to be able to see it, see the differences. If you're colorblind, you'll still be able to see the differences when you start to use different lightness there and tint. Moving on here. So I wanted to give some technical tips and just kind of looking at the time here, I'm going to kind of run through some direct tips that you can use with Spotfire. So the number one tip right here is to pick a primary color. So this is a demand forecasting dashboard with coffee sales. I picked a primary color in my visualization, custom canvas visualization. It's in the canvas styling. The canvas styling went to the custom theme. And what that does is by picking a primary color, it gives you something very consistent to go off of and creates a lot of harmony. And so that you don't have a lot of different colors on different pages that are distracting to the viewer that's just trying to get the insight. So it actually makes all the bars the same color, these like highlights the same color. It'll make the buttons this same green color. And then I chose to, if I have a chart and I don't need to use color to emphasize anything, I don't know what color to make it, I just use my primary color. I use that across the dashboard. You also want to consolidate your text areas. So if you have all these separate text areas, I use some HTML formatting and I put these together. And what that allows me to do is lock the text area to the corner. And that prevents, if I make the page smaller, these little bars don't show up, these little scroll bars. If you make it one text area, you can lock it to the corner. Spotfire allows you to lock visualizations to the edges of a page. With fonts, sans serif fonts are the fonts that don't have these little ends to the fonts, and that is a little bit easier on the eyes to read. So I've used a lot of sans serif fonts here. I don't use bold, and I try to stay to three font sizes on a single page. Remove obvious axis labels. So if I have this monthly demand in my title, then I don't really necessarily need the demand axis there, and I don't need the date here because that's obvious. And you can remove that from the drop down in the toolbar, or in the title bar there. To use clean axis labels, this can actually make a big difference. So this is a messy column name. So I clean up all my axis labels as a last tip, or a last styling polish. I also try to use a white tooltip on white backgrounds or light colored background dashboards. And then I use instead of using a dark tooltip, I'll use a dark tooltip on dark dashboards. You also want to make sure you clean up your tooltips. Don't have a bunch of redundancy. Don't have them poorly named. You can use a geometry if relevant. So these are little final touches that will help clean up your dashboard, remove clutter, turn off the color stripe for related tables. I like to turn that off, and that's in your file document properties. Try not to use weird marking colors. You can see this pink here stands out. I used a subtle gray, and that isn't so jarring. There's other obvious things like clean up your legends, remove unuseful information, remove titles, and you can also avoid legends when possible to clean up space. And you want to format numbers appropriately. So I like to put commas on my integer values that are over 1,000. You don't want to have a bunch of decimals either if these are small integers. I'm going to just kind of move on here. So use maps that have appropriate geospatial context. So this coffee store thing is looking at different stores. The roads don't matter so much in this visualization, in this map visualization. So I have a very muted map background. But this is a routing one. And so I've used a satellite imagery so you can actually see around Seattle here and see that context. And then this is for Airbnb sales, and it's actually showing a little bit of the topography, where the parks are, where the waterfronts are, where the major roads are. So if the data doesn't benefit from the geographical context, try not to use it in your map backgrounds. And you can change your map backgrounds as a default. So it always automatically drops in a satellite layer or a light layer. You don't have to do it each time. You can change it into your defaults, and you can get custom layers from this link as well.
Yeah, bottom line is to make the ink matter with respect to information communication. So,
exactly.
Yeah.
It's all data to ink ratio, right? So you don't want a bunch of reference ink if it's not valuable to the data insight.
Exactly.
All right, so just some before and after applying principles. So this is on the top left, you'll see the old dashboard. On the bottom right, you'll see some of the edits. So I set a primary color to the Wikipedia blue. I styled it like a Wikipedia page. I removed all the excess colors. The map background is actually white, and I used a geocoding table just to put the shapes in. So very simple. I really simplified that and used just kind of style of a simple Wikipedia page. I de-emphasized the map background here. I changed this color scheme from diverging to categorical, since it was categorical data. Consolidated the text areas, removed bolded fonts. This was an interesting one because this is a violations and alarms in a manufacturing scenario. And the person that designed this had created these KPIs that went from red to green. And what it was doing in the middle was creating these brown colors. And it didn't really feel like it was helping to have these as different colors at all because you have the value right there. So I just made them the same color. I standardized kind of all the gradient of colors there. I took out the weird marking value there. I consolidated the text areas into one area here, things like that. And I made the filters, instead of having just this filter with this checkbox, I made the filter into buttons using bookmarks and action controls. I'm going to skip over that one because I think this one is better to show. So this is on heart disease patients in Canada, and I moved the map to make it larger as the focus. I turned the bar charts horizontal so you can read the labels better. I reduced the number of colors on the page. There's a lot of different colors happening. I made the map background more subtle because we don't want all of this detail. I removed axis labels like here, things like that. And I also, this is an ML dashboard and on predicting heart disease or in variable importance of heart disease. And I added a new page on just setting up the context of the data first. Here's some visual examples of using a dark background, and here are some visual examples of using a light background as an example. With that, I think we're got like a minute left. Just say
Yeah, you got to wrap it up and put up the credits page or the contact page or something. Yeah.
Yeah, our next session will be data function tips with Python, or I might have a couple other data scientists joining. So keep that in mind, first Tuesday of June. Yeah, thank you all for joining. We are right up at time. And Michael, thank you so much for enlightening us with all of your experience. And
It's an honor to be on the Dr. Spotfire session, Neil. It's an awesome session. I love coming and watching them with interest. So I hope I was able to contribute something today. Thanks, everybody, for using Spotfire and being engaged in our community.
Yeah, thank you very much, everyone. And we'll try to get to these questions and email you back on those. Thanks.